Hey guys, today we are looking at our very last section of Chapter 4, 4.8. Technically it's analyzing polynomial functions. Here I know I have it titled Graphing Polynomial Functions. It's kind of looking at both sides of the coin and kind of just putting everything back together. So we're going to be looking at both taking a look at my equation that has already been graphed and working backwards to figure out what that equation was, or we could start again with an equation and work to graph it. So just a quick little recap on multiplicity. So we know that our x-intercepts are our zeros. Those are our solutions to the equation. So we know anywhere that equation touches or hits the x-axis, those are where my solutions are. And it could go straight through the x-axis, but remember also it could be the case if the curve just barely touches the x-axis as well. Which again brings us back to talking about multiplicity, which is when we have the same solution to my equation that appears multiple times within my polynomial. So we know these are our we're going to go down here to the multiplicity guide real quick. I know we've already gone through this before, but just to remind you, we have three different ways that we could have multiplicity that we have seen in this class and will see in this class. We have a multiplicity of 1, which is where my graph goes straight through. Is a multiplicity of 1. Again, it could be either direction, going through, up or down, really depending on your philosophical beliefs. Multiplicity of 2 is where it bounces. Or touches, I guess you want to say. But I always say bounces because it goes down, hits it, and then turns back the other way. It bounces off of that x-axis. And it could be approaching from above or below. Both of these two are bouncing at the x-axis. And then our third one, our multiplicity of 3, that is where we have when it hesitates. So if we're approaching from below, it kind of gets close, it kind of slows down, and then goes through. You can see that little curve. It's almost like if you took a parabola and flipped one side up. Or we could have the other way. If it comes from above, it's going to come to it, kind of hesitate, slow down, and then continue through. Again, that would be a solution still where it actually hits the x-axis, but here because it hesitates and kind of slows down, curves towards the x-axis, and then curves back down, that's a multiplicity of 3. So looking back here at our original problem that we were given, we have two x-intercepts. We have one here, and we have one here. And that point, that left one, is at -2, x equals -2. And we know that since it bounces at -2, that means it has a multiplicity of 2. Now, because my x intercept is -2, the factor would be x equals 2. Because remember, our solutions, x equals -2, that's what I get when I set my factor equal to 0. So if x equals -2, well, working backwards, I would have to add 2 on both sides to get it equal to 0, which is why x plus 2 is the actual factor, what I see in my equation, I see in my parenthesis as that factor. Now, because it has a multiplicity of 2, we would actually write it as a squared, x plus 2 parentheses squared, because that's going to give me two instances where I have -2 as a solution. My other one here, this right x-intercept at +3, is just a single solution, right? It doesn't have any multiplicity, it just goes straight through. So x minus 3 would be that factor. Again, it's always the opposite of what the number actually is because, again, we have to solve it for 0. So x minus 3 is that factor because +3 was a solution. So if I wanted to try and combine these together, we'll just call this f of x, the equation in factored form, not having to fully expand it all the way out, x plus 2 squared, x minus 3. Now, it depends whether you have to go one step further and actually multiply those out or combine those together into just standard form, depends on what your instructions are. If it doesn't specify that it has to be in standard form, you can leave it factored out like this. I'm totally fine with that. It's just a lot of extra work. You've already shown me that you are capable of multiplying factors together, multiplying polynomials together. So you don't have to do that on this problem unless it specifically says your answer needs to be in standard form. All right, so let's take a look at another example here. So this is kind of how I usually format it, just to kind of get a full idea for what it looks like. Now with this up above, we assumed that everything was just positive, right? We just assumed that the factors were exactly as they were supposed to be, with no other kind of weird hanky-panky stuff going on in the background. But actually, this equation that I wrote is not correct, because if you look here, my right side points down, which means I should have a negative leading coefficient, so this equation is actually incorrect. So we're going to go ahead and incorporate that, all the information that we know together to try and write our equation as accurate as possible. So first things first, I always start with the easy part, which is my intercepts. I have, again, only two x-intercepts, which means I only have two solutions, +2 and +4. Those are my two solutions. I always just describe what the multiplicity is. So my +2 has a multiplicity of 2 because it bounces at that x-intercept. My solution of 4 has a multiplicity of 3 because, again, it does that little hesitation. You can see what it looks like in an actual graph here. So as a factor, again, trying to combine these two things together, we know x minus 2 is going to be the factor that gives me a solution of +2. And since it has a multiplicity of 2, it's going to be x minus 2 squared. For my other one, I know that +4 is my solution, so my factor would have to be x minus 4, and that's going to be cubed because it has a multiplicity of 3. Now the next two things are going way back to the first section of chapter 4 with the degree and the direction. So degree, again, this is either going to be even or odd. If they both point the same direction, either both up or both down, it's going to be even. In this case, the left points down, the right points up, which means it's going to be odd. And then direction is just what the right side does. If it points up, it's positive, like it is in this case. If it would point down on the right side, it would be negative, but in this case, it's positive. So our equation is going to combine all of these things together. You're going to start with your factors. Your factors in this case are, we'll say f of x. We're going to do this in blue. F of x equals x minus 2 squared, x minus 4 cubed. And then from here, this is where you check to see, does the other stuff match? Is this odd? Well, a degree of 2 plus a degree of 3 is a degree of 5, so that's so far so good. And my leading coefficient here, which is 1, is positive, so I'm good there as well. So again, if my equation doesn't say, or my instructions don't say, write your answer in standard form, that would be good. That's all you have to do. Okay? We're going to take a look at a couple more examples here, a couple more examples of those. All right, so now I've got 1, 2, 3 solutions. I've got -2, 0, and 1. -2 and 0 both have a multiplicity of 2 because they bounce at those intercepts. And then +1 just has a multiplicity of 1 because it goes straight through. So this is x plus 2 squared, because again, opposite of that. This middle one is a little bit tricky because it should be x minus 0 squared, but we're going to go ahead and just ignore that minus 0 because we know that doesn't do anything. X minus 0 squared is the same thing as just x squared. And then my last one, x minus 1, is just to the first power. I don't need to write another exponent on there, so we're good. Looking at my graph in general, the degree is odd because they point opposite directions. And in this case, it is negative because the right side points down. So negative. So looking at my factors, 2, 2, and 1 add up to 5. So that is odd, which is good. So y equals, or f of x equals. I need my direction to be negative, and all three of these are positive leading coefficients. So I'm going to have to just add in that negative out in front. So negative x squared, x minus 1, x plus 2 squared. Order does not really matter. We know that multiplication is commutative, meaning it doesn't matter what order you multiply in. I usually just like to keep if I have an x squared term, we'll just leave it out in front, and then I go ascending exponents after that. But As long as you got the negative and then each of those three factors, it doesn't matter what order they're written in. All right, last one of those type. I've got 1, 2, 3 solutions. Looks like -3, -2, and +1. -3 has a multiplicity of 1. -2 has a multiplicity of 2 because it bounces. And then +1 has a multiplicity of 3 because it does that hesitation again. So x plus 3 is that factor to the first power. X plus 2 squared because the multiplicity of 2. And then x minus 1 cubed because it's got a multiplicity of 3. Now this is one, we finally have one that's even because they both point up, which means positive for the direction. And if you look at adding up all of your exponents for your factors, 1 plus 2 plus 3 is 6. So I am happy because it is even degree. So y equals x plus 3, x plus 2 squared, x minus 1 cubed. That would be my final answer there. All right. So going the other direction, now that we know how to pull factors and equations out of a graph, let's reverse that process and sketch some graphs with more accuracy than we have done in the past. So here we were given our equations in factored form, which is nice because that tells us what our solutions are, tells us what our x-intercepts are, which is just awesome. So for e of x here, -5 is my first x-intercept. +3 is my second one, and then 0 is my third. Because all I'm doing for those three factors is just setting them equal to 0 and solving. If I look at the degree, I've got degree 1, degree 1, degree 1. That's a total degree of 3, which is odd. My leading coefficient out here in front is positive, which tells me that in general, since it's odd, they point opposite directions. And positive tells me what the right side does. So that means I should be positive, right? Up on the left or the right, down on the left. Right side's positive, so that's how it should go. Now all three of these have just a degree of 1, so they're going to go straight through. No hesitation, no nothing else like that. The other nice thing here is that I know my y-intercept. That's the other big thing that we utilize is the y-intercept. Here it actually is at 0 because it was one of my y-zeros, one of my solutions. So I know exactly where it crosses the y-axis as well. That would be the only other point that you would be required to incorporate. So for this, again, I'm just going to do a sketch, going through, end up on the right, and that's all I need. I don't need to do anything else fancy with it. I'm fine leaving exactly that way. So we're good. Taking a look over here at g of x. This one is going to require a little bit more work. We're still going to start with my zeros. I've got -4, -1, and +2 for my 3 zeros. Those are my 3 x-intercepts. That would be solving each of those parentheses for 0, or setting them equal to 0. So -4, -1, and +2 are my solutions. It is negative for the direction, and my degree, I've got 2 plus 1 plus 3 is 6, which is even. So even and negative means I should be down on both sides. Down on both sides. The other thing I need to incorporate again is my y-intercept, because that could change how my graph looks quite a bit. Now, this one, there's an easy way of doing it, and there's a more difficult way of doing it. We know that my y-intercept is my constant. My y-intercept is my constant, but I don't have my answer in standard form here. So the easier way of getting your constant without having to multiply everything together, we also know that the y-intercept is the point that has the y value when my x value is 0. So what all I'm going to do is plug in 0 for my x value. And then solve for y. Well, negative 4 squared times 1 times negative 2 to the third power. Well, that's negative 16 times negative 8, because negative 2 to the third is negative 8. So that ends up being a positive 128. Oofda. Oofda, oofda, oofda. So I'm going to have to just kind of pretend that I go all the way off my graph and do this. We're just going to put a point way, way up here as high as I can and say that this is 0, 128. Because it just does not make sense for us to be scaling by that much. We're just going to make it super, super steep and just say, hey, look, that point's supposed to be 0, 128. So some other things to keep track of, and you can kind of do this at first if you want to, or just keep track of it as you go through. My negative 4 has a multiplicity of 2, so it should be bouncing at negative 4. My x-intercept of negative 1 has a multiplicity of 1, so it should go straight through negative 1. And then my solution of 2 hesitates because it has a multiplicity of 3, so I have to make sure I incorporate all of those things. So what that's going to look like here, it's going to bounce at 4, go straight through 1, go way up there to 128. It does that little hesitation thing on the right side at negative 4, or sorry, positive 2, and that would be it. Now, I'm not super thrilled with how that turned out, so I'm going to go ahead and try that again. Let's go ahead and bounce straight through. No, I don't like that part there. There we go. That's a little bit better. Still not super thrilled with it, but it is what it is. It bounces at negative 4. It goes straight through negative 1. Y-intercept of 128. And then my hesitation there at positive 2. Down on both directions because that's even and positive. It's all we need to incorporate. It's everything that we know. So that is it for 4.8. That is actually it for Chapter 4 as well. Here is your homework, page 216, 3 through 16 all. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. And I will see you guys soon. Have a fantastic day.